Now, the process of interpolation and process of curve fitting almost philosophically are the same, but the process of curve fitting gives you much more information than interpolation, because interpolation or extrapolation, you are seeking the value of the dependent variable at certain value of the independent variable, but the curve fitting would give you the entire information, that is the entire relationship between the two. Though we are trying to solve a typical university problem on Newton backward interpolation, what we are also simultaneously doing is we're giving you complete clarity on the problem by actually doing the curve fitting. You can do curve fitting using, say for example, Lagrange interpolation, or you can adopt any other interpolation, but what happens is that gives you the complete picture. So let's look at first the Newton backward difference method for this particular problem, and subsequently we'll look at the curve fitting and an explanation for why exactly you get 31 when you are getting just 1 minus 1 1 minus 1 for 1 2 3 4 5. Suddenly when you seek value for x equal to 6, the value of y, you are going to get 31, and that is going to be explained using curve fitting. Now let's get started with this particular problem. As usual, the table would be given to you, and you are asked to find x equal to 6. Since x equal to 6 is the independent variable that is very, very close to xn, that is 5, we are going to use the Newton's backward difference method. So how do you actually implement this interpolation situation? So this is very simple. First, I am going to tabulate x, I am going to tabulate y, and then I am going to calculate the backward differences. The first order backward difference, the second order, third order, and the fourth order. So how do you actually calculate? It is minus 1, which is minus 2. And then 1 minus of minus 1, which is plus 2. And then you have minus 1, 1 minus 1, which gives you minus 2. And then finally 1 minus of minus 1, which is plus 2. And you can see that we have marked these leading differences in red, because these are going to be implemented in the formula for estimating the value of yn. And how do you calculate the second order differences? It is 2 minus of minus 2, which is 4, minus 2 plus 2, minus 2 minus plus 2, which is minus 4, and 2 minus of minus 2, which is 4. And then you have the difference between these two, that is minus 4, 4, which will give you minus 8, and 4 minus of minus 4, which is plus 8. And since you have 8 and minus 8, the difference would be 16. So very, very easy to calculate this table, basic arithmetic operations. Now we have got the leading backward differences. The first order difference is 2, the second order difference is 4, the third order difference is 8, and the fourth order difference is 16. So how do you actually implement this? You are going to implement in the standard formula that we discussed in the introduction. And you can see here that yp gives you the value that you are estimating for the independent variable x equal to 6. Up to 5 we have been given. In fact, we are extrapolating for x equal to 6. And since the value that we are trying to estimate is close to the xn, the p is calculated as follows, because it is x minus xn divided by the difference in the independent variables, because they are all equally spaced, because this interpolation what we are doing is for equally spaced data points. But if they are unequally spaced, then we will go to Newton's divided difference method. But now here it is x minus x1 divided by each independent variable is differentiated by 1, that is value of 1. The difference between consecutive independent variables is 1. So therefore I am going to divide this by 1. X is what? X is 6. And what is xn? You can see xn is 5. So 6 minus 5 by 1. So p is 1. And you very well know why we use this symbolism n, because our estimation is close to the nth independent variable. Otherwise, we use a symbolism 0 here for forward difference, indicating that it is close to the first independent variable. So now we have calculated p. We know the value of these backward differences: first order difference, second order, third order. Of course, we have got a term for fourth order. That means I will also have to incorporate this particular coefficient, p into p plus 1 into p plus 2 into p plus 3, and divided by 4 factorial, which is, of course, we haven't mentioned here. We have truncated at the third order difference, but this also comes along with it. What you get is n raised to the power 4, because we are seeking the fourth order difference. And also nebula are the del operator which we used in vector calculus. The same operator is used for the backward difference, otherwise it is delta for the forward difference. Now let us substitute one by one. So yp gives you the estimated value for x equal to 6, and you can see here that yn, that is the value corresponding to x equal to 5, which is our base. X equal to 5 is plus 1 here. You can see this is the value that I will have to take. So that I am placing it here. That is my base value. Then what about my first order backward difference? That is 2, and that is multiplied by p. So this term becomes 2 here. And what about the next term? The second order difference is 4. That comes over here. And if you calculate p into p plus 1 by 2 factorial, that turns out to be 1, because you can see 1 plus 2 divided by 2, which is nothing but 1. So therefore we have put 1 over here, 1 into 4. What about the next third order backward difference? It is 8. And again you are going to get 1. The advantage is very good here, because when you substitute p is equal to 1, again this turns out to be 1. When you put p is equal to 1 for even the fourth order difference coefficient, it turns out to be 1, simply because it is 1 into 2 into 3, because it becomes a set of natural numbers. So therefore whatever factorial here you have, that is nothing but that is present in the numerator. So therefore every time you put p is equal to 1, this coefficient for any order of difference, be it even the nth order difference, turns out to be 1. That is where you can see that here also you got p is equal to 1. That is a trivial case, but you can see here for the second order difference, p into p plus 1 by 2 factorial becomes 1. That is where we have put the 8 into 1. And then what you have here is p into p plus 1 into p plus 2 by 3 factorial, 8 again into 1. And then when you put for fourth order p is equal to 1, it is 1 into 2 into 3 into 4, which is 4 factorial, again that becomes 1. So therefore whether you are talking about p into p plus 1 by 2 factorial, that is here, you get 1. Whether you are talking about p into p plus 1 into p plus 2 by 3 factorial, you get 1. And whether you are talking about this, you get 1. So therefore if you add up all that, you are going to get 31. So this procedure is very trivial, but what is very intriguing here is that why do you get 31? If you observe, for independent variable 1 you are getting just 1, for independent variable 2 you are getting minus 1, independent variable 3 you are getting plus 1, 4 you are getting minus 1, but suddenly 5 also plus 1, suddenly when you say 6 you are getting 31. So that is difficult to assimilate unless we do curve fitting, and that is where we are going to do the following exercise, just to give you clarity how exactly this has to be interpreted. See, we are given these 5 data points. That means we can fit a polynomial of degree 4, right? Because you just consider this fact: y is equal to ax plus b. How many variables does it involve? It involves two variables a and b to be fixed in order to get this relationship. I need to fix the value of a and value of b in order to fix this relationship, linear relationship, and the order of x is 1. So how many points I require? I require 2 points. If there are 2 points, I'll be able to get a and b, and the degree of polynomial will be x power 1. If I say y is equal to ax square plus bx plus c, there are three components that I need to find the value a, b, c. How many points I require? I require 3 points. That means 1 point less will be the degree of polynomial that I would be working with. Similarly, if you looked at the 4th degree polynomial, how many variables I'll have to, rather how many components I need to find? The coefficient of x power 4, the coefficient of x cube, the coefficient of x square, the coefficient of x, and the constant term. So there are 5 points. So but I'm given 5 data points. That means I would be able to find those 5 constants, or I'm going to fix the curve of degree 4 because I'm given 5 points. That's very clear. So now once I use either Lagrange interpolation or any other technique to arrive at this particular curve, what happens? You would be able to appreciate the fact. Observe the curve in 2 parts, because suddenly the value jumps. So what we did is we have considered the 31 for x equal to 6 in a different curve, but for all other data points we have considered this because the value of y remains very, very low. But suddenly the value of y jumps to 31 when you say x equal to 6. That is why we have considered 2 graphs. Look at this particular graph being plotted here. You can see when x is equal to 1, you can see the value of y is plus 1. So the value of y is plus 1 when you say x equal to 1, right? Similarly, x equal to 2, what happens to the value? You drop a vertical and you would find that it is minus 1. You can see this is minus 1. Minus 1 line, this is plus 1 line. So here you have got y is equal to minus 1. The moment you talk about x equal to 3, what happens? You can drop a vertical and you find that y is equal to plus 1. It is like just alternating, right? Very easy to remember also. 1 plus 1, 2 minus 1, 3 plus 1, 4 again minus 1. And look at this. At 4, x equal to 4, if you drop a vertical, you would find that y is again minus 1. Right? Isn't that very, very easy to observe? And again, when it comes to 5, if you're this is our x-axis, this is x equal to this is x equal to 5, this is x equal to 5. If you drop a vertical, you can see again you get y is equal to plus 1. You can see it has alternated beautifully. When x equal to 1, plus 1. When x equal to minus 1, it is minus x equal to 2, it is minus 1. And x equal to 3, it is plus 1. X equal to 4, it is minus 1. X equal to 5, it is plus 1. Right? So this is very well understood. But what happens the moment I put x equal to 6? You can see here, the moment I put x equal to 6, it jumps to 31. It jumps to 31. That is where the nature of the curve has to be understood and its sensitivity. So, for example, you are trying to think this as a physical phenomenon or some kind of response as y for certain input. You can see when your x's are 1, 2, 3, 4, 5, the response remains very, very subdued. The moment you put x equal to 6, the response skyrockets. And this kind of information was possible only via curve fitting, right? But otherwise, you could not have discovered what is the value of, the justification for a large value of y is equal to 31 at x equal to 6. You have just estimated it in interpolation. And also the advantage is for any value in between, you can easily pick from the graph, because the moment you represent something graphically, that is going to reveal host of informations. If you want to seek the curvature at any point, you can do that. If you want to seek slope at any point, you can do that. But interpolation is comparatively very, very less powerful compared to curve fitting or regression. So therefore, this becomes a more efficient way of understanding things. So let's move on and look at more discussion. But before that, let me walk you through what exactly we did. So let me get rid of all this to give you clarity again what we did. Just to reiterate, we started with this particular table and we were asked to find the value of y for x equal to 6. The observation is very clear. X equal to 6 lies very close to the xn, so therefore we adopt Newton's backward interpolation, right? And how do you calculate p for this? It is simple. It is x minus xn, which is 5, divided by the difference between these data points. All are equally spaced data points. You can see 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. If they are not equally spaced, then you will have to go for a different Newton's divided difference interpolation. So, but now here it is 1, so therefore this is p is equal to 1. One thing we observed, that the coefficients of all the backward differences, whether it is the second order difference, third order difference or fourth order difference, will be 1, because p into p plus 1 into p plus 2 up to nth term p plus n, and divided by n plus 1 factorial. If you are trying to do, it's going to be 1, because you can see, for example, if I do p into p plus 1 divided by 1 plus 1 factorial, that is of course 2 factorial, it is going to be 1. And if you did it for 3, if you did it for 4, if you did it for any number of terms, it turns out to be 1. So therefore, in fact, for this particular problem where p becomes 1, you can rewrite this formula as follows. Because all the coefficients turn out to be 1, you can say your estimated value at x equal to 6 is nothing but your base value, that is this value, because you are estimating very close to x equal to n, so that becomes your base value. So this is for x equal to 5, plus p becomes 1, so therefore it is simply delta del yn, plus since the coefficient becomes 1, it is del square yn plus del cube yn plus del power 4, since we have fourth order difference, del power 4 yn, and n signifies that it pertains to xn. Okay, so therefore what happens, y5 is nothing but 1, and if you simply add up the leading backward differences, it is 6 plus 8, which is 14 plus 16 is 30, so simply that turns out to be 31, right? So this is very, very basic, and you know how to create this table. You have to subtract from minus 1 plus 1, that is from the number which is below, the above number has to be subtracted. So from the below number, above number has to be subtracted. Minus 1 minus minus 2, 1 minus 1 plus 2, minus 1 1 minus 2, 1 minus of minus 1 plus 2, and this continues. And you can see 2 minus 2 plus 4, minus 2 2 minus 4, 2 minus 2 plus 4, minus 4 4 minus 8, 4 minus of minus 4 plus 8, 8 minus of minus 8 plus 16. That is how you get. Once we did it, we wanted to understand this fact, which comes about as a shock, because till 1 2 3 4 5 you have just the value alternating between plus and minus 1. Suddenly at x equal to 6, why does it shoot up to 31? And that is where we curve fitted this particular situation, and you can see that this is exactly the curve. And one of the important ideas I told you is that if are having 5 points, you can fit a curve of order 4. Why? Because you need to find out 5 components, that is coefficient of x power 4, x cube, x2, x, which is 4, plus a constant term. That means if you have 5 points, you can easily fit this particular curve. And you can see, once you fitted the curve, you can clearly see that for all values x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5, you can clearly see x equal to 1 you have got positive y, and x equal to 2 you have got negative y. All that you got to do is from the x you drop a vertical to the curve, right? You can't drop a vertical in the upward direction, it has to come down. And 3 if you drop a vertical, y is equal to 1. From 4, if you drop a vertical, minus 1. From 5, if you drop a vertical, plus 1. But for y is equal to x equal to 6, if you drop a vertical, it hits the curve at 31. So that is very, very important. So with that, let's move on and look at more problems. Well, engineering and math are absolutely inseparable. We interventions day in and day out try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.